There's this classic debate in the world of software development. It's this gap between the super abstract stuff you learn in a computer science class and what you actually do day to day as a professional coder. So the big question is, do those fundamentals really matter once you're in the trenches? Let's get into it.
Yeah, for so many of us, this is where it all started, right? A college course, a textbook that weighs a ton, and this promise that everything inside is the bedrock for your entire career. It's all about pure structured logic.
Okay, so what exactly are we talking about when we say the classroom foundation? Well, it really all boils down to one central idea: the algorithm. Now, in academia, an algorithm isn't just some vague plan. Nope, it's a very, very precise thing. It's a specific, written set of instructions that's designed to give you a predictable, reliable result every single time.
And it doesn't just stop with the definition. Oh, no. The textbook lays out these really strict rules for what makes a good algorithm. It has to be finite, meaning it can't run forever. It has to be unambiguous. Every step needs to be crystal clear. And it's got to be effective, meaning you can actually do each step. It's all part of this super structured, almost mathematical way of thinking they teach you.
And this, right here, perfectly shows that methodical process you're taught. You don't just jump in and start hammering out code. No way. You define the problem, you design the logic, you map it out, you test the theory, and then, only then, do you actually implement it. It's this very deliberate, step-by-step approach. But does anyone in the real world actually do this? Well, that very question takes us from the clean, theoretical world of the classroom and drops us right into the messy reality of a professional code base. And it all started with a question from a developer on Reddit.
And there it is. The question that I think is on pretty much every developer's mind at some point. This person's a full-stack web developer, and they're basically asking, did I miss something? They learn all this complex theory, but in their actual job, they're just not using it. It's a feeling a lot of us can definitely relate to.
So as you can imagine, this one question just opened up the floodgates. It sparked this huge debate that really shows how divided professional developers are on this whole topic.
I mean, you literally could not get more polar opposite than this. On one hand, you've got developers flat out saying, nope, never touch that stuff. And on the other, you have engineers saying they use it pretty much every single day. So what is going on here? Who's great? This comment kind of gets to the core of one side of the argument. For a lot of developers, especially if you're in web dev, the job is often about putting together pre-built pieces and connecting to different services. The argument is that they're not trying to solve these huge, complex computer science problems from the ground up, so why would they ever need to write a custom sorting algorithm? But then, here comes the counter-argument, and this is the absolute key to the whole thing. The debate isn't really about whether algorithms are being used, because they are. They're everywhere. The real question is whether you need to know how to write them yourself from scratch. Every time you use a simple sort function, you're standing on the shoulders of a giant who already wrote that algorithm for you. Okay, so this is where we start to build that bridge between the two camps, because the answer isn't a simple yes or no. The value of all that classroom theory, well, it isn't as direct as you might think, but it turns out to be incredibly important in a totally different way. Which brings us right back to that core anxiety, right? If all the libraries and frameworks are handling the heavy lifting for you, did you just waste your time and money learning how a quicksort works? Is all that knowledge just useless trivia for a job interview? And here is the big aha moment. This is the key insight that came up over and over again in that discussion. The real practical value is not being able to scribble a binary tree on a whiteboard. It's about understanding why you would choose one tool over another. It's all about knowing the trade-offs. Let's make this super concrete. Think about a simple choice you might make every day, using an array versus a set. Let's say you have a list of things, and you need to get rid of all the duplicates. Sure, you could loop through an array and write some logic, but if you understand the fundamentals, you know that a set data structure is designed for unique items and does this for you, way more efficiently. You don't have to code the set yourself, but just knowing it exists and when to use it, that is the real-world application of the theory. That's the trade-off in action. So you see, the big point here is that maybe we've been asking the wrong question all along. The whole point of learning the fundamentals isn't just to be able to recite definitions. It's about developing a much deeper and way more valuable skill. This is the real prize. It's about building a mental toolkit. It's having the ability to look at a new problem and not just grab the first solution that comes to mind, but to actually see the whole landscape of possibilities and pick the best one. It's knowing why your language's built-in sort function is perfectly fine 99% of the time, and being able to spot that rare 1% where it might be a problem.
And as this experienced developer points out, this kind of knowledge is evergreen. The frameworks you use today will be old news in 5 years, but the core principles of how to structure data and solve problems efficiently, that knowledge stays with you for your entire career. It's the foundation for really high-level skills like software architecture.
So, in the end, it turns out the classroom and the codebase aren't as far apart as they might feel. The true value of that textbook isn't to give you a bunch of recipes you'll follow step by step. Its value is in teaching you the principles of cooking so that you can walk into any kitchen with any set of ingredients and create something that's efficient, powerful, and built to last.